200 amp panel's maximum amperage isn't explicitly defined in the National Electrical Code, but a common guideline suggests limiting the load to 80% of the panel's rating. Therefore, a 200 amp panel shouldn't consistently handle more than 160 amps. This safety margin helps prevent several potential problems. Firstly, exceeding the 80% threshold can lead to frequent tripping of circuit breakers. Circuit breakers are designed to protect electrical circuits from overcurrents. When the current draw surpasses the breaker's rating, it trips, interrupting the power supply to prevent overheating and potential damage. Overloading the panel increases the likelihood of these nuisance trips, disrupting power to various circuits within the building. Secondly, consistently overloading an electrical panel can cause it to overheat. Electrical resistance generates heat as current flows through conductors and components within the panel. When the panel is loaded beyond its capacity, the excessive heat buildup can degrade insulation, damage components, and potentially create a fire hazard. The 80% rule provides a buffer to minimize heat generation and maintain safe operating temperatures. To determine the actual load on a panel, add up the amperage of all the circuits connected to it. Consider both the continuous and non-continuous loads. Continuous loads are those that operate for 3 hours or more at a time, while non-continuous loads are those that operate for shorter durations. The NEC mandates that overcurrent protection devices and conductors be sized to handle 125% of the continuous load, plus 100% of the non-continuous load. For example, if a circuit has a continuous load of 10 amps and a non-continuous load of 5 amps, the breaker and conductors must be rated for at least 12.5 amps plus 5 amps, totaling 17.5 amps. Therefore, a 20 amp breaker would be required. To calculate the total load on the panel, sum up the loads on all the individual circuits, taking into account the 125% factor for continuous loads. Then compare this total to the panel's rating. If the total load exceeds 80% of the panel's rating, it's necessary to reduce the load or upgrade the panel. Reducing the load can involve identifying and eliminating unnecessary electrical consumption, shifting loads to different circuits or panels, or implementing energy-efficient measures. Upgrading the panel involves replacing it with a higher rated panel that can handle the increased load. This typically requires professional installation and may involve modifications to the electrical service entrance. Several factors influence the appropriate panel size for a given application. These include the size and type of building, the number of occupants, the types of electrical appliances and equipment used, and the anticipated future electrical needs. A qualified electrician can conduct a load calculation to determine the appropriate panel size based on these factors. The load calculation involves assessing the total electrical demand of the building, taking into account both existing and future loads. It considers factors such as lighting, receptacles, appliances, HVAC systems, and other electrical equipment. The electrician will use the NEC guidelines to determine the minimum panel size required to safely and reliably serve the building's electrical needs. When selecting a new electrical panel, it's important to consider several factors beyond just the amperage rating. These include the number of available circuit breaker spaces, the type of busbar material, the enclosure type, and the manufacturer's reputation. The number of circuit breaker spaces determines the number of circuits that can be installed in the panel. It's generally advisable to choose a panel with more spaces than currently needed to allow for future expansion. The busbar material is the conductive material that distributes electricity within the panel. Copper busbars are generally preferred over aluminum busbars due to their higher conductivity and resistance to corrosion. The enclosure type determines the panel's suitability for different environments. Enclosures are rated based on their ability to protect against dust, moisture, and other environmental factors. The manufacturer's reputation is an important consideration, as it reflects the quality and reliability of the panel. Choose a panel from a reputable manufacturer with a proven track record of producing safe and durable electrical equipment. Regular maintenance of electrical panels is essential to ensure their continued safe and reliable operation. This includes periodic inspections to check for signs of damage, overheating, or corrosion. It also includes tightening loose connections, cleaning dust and debris, and testing circuit breakers to ensure they are functioning properly. If any problems are detected, it's important to have them repaired by a qualified electrician promptly. Working with electricity can be dangerous, and it's essential to take appropriate safety precautions. Always disconnect power before working on any electrical equipment. Use insulated tools and wear appropriate personal protective equipment, such as safety glasses and gloves. If you're not comfortable working with electricity, it's best to hire a qualified electrician. In summary, while the NEC doesn't explicitly state a maximum amperage for a 200 amp panel, adhering to the 80% rule is crucial for safety and reliability. Overloading the panel can lead to trip breakers, overheating, and potential fire hazards. Calculating the total load in a panel, considering both continuous and non-continuous loads, is essential to ensure that it remains within its rated capacity. If the load exceeds 80%, reducing the load or upgrading the panel is necessary. Selecting a panel with sufficient capacity, quality components, and appropriate enclosure is also important. Regular maintenance and adherence to safety precautions are essential for ensuring the continued safe and reliable operation of electrical panels. Remember, if you're unsure about any aspect of electrical work, it's always best to consult with a qualified electrician. They have the knowledge, skills, and experience to ensure that electrical systems are installed and maintained safely and in accordance with the NEC and local codes. Ignoring these guidelines can have serious consequences, potentially jeopardizing the safety of people and property. Electrical systems are complex and require careful attention to detail. Proper planning, installation, and maintenance are essential for ensuring their safe and reliable operation. Consulting with a qualified electrician is always the best course of action when dealing with electrical work. They can provide expert guidance and ensure that all electrical work is performed safely and in accordance with applicable codes and standards. By following these guidelines and seeking professional assistance when needed, you can help ensure the safety and reliability of your electrical system.